In this video, you are going to discuss class 11th Mathematics Chapter 1 Sets Solutions to Exercise 1.6. Before going to the video, please visit the introduction part of Exercise 1.6. See the link below in the description box for the previous videos on sets. Before going to solve the problems in the Exercise 1.6, I am giving you some important formulae and its Venn diagram. See, these things are discussed in the previous video also, but I am giving the important formulae with. I am going to explain the formula with respect to this Venn diagram so that it is more comprehensible. If you understand this formula and this Venn diagram, all the problems of exercise 1.6 can be solved very easily. This Venn diagram is again intersection of two sets, and you have this pink portion is A minus B, and this white portion is A intersection B, and this green portion is B minus A. This is A minus B, this is A intersection B, and this is B minus A. Now these three are disjoint sets. This is A minus B, B minus A intersection B are disjoint sets, and their union is A union B. The complete union of A and B. Two intersection sets. Now see this formula. A union B. Number of elements in A union B is number of elements of A plus number of elements of B minus number of elements of A intersection B. And second one is A intersection B is a null set. Then these two sets are not intersecting. Then straightforward, it is A intersection A union B is NA plus NB. Simply you add the number of elements of A and number of elements of B. Third, NA minus B. See, what is this A minus B? This piece is what? NA minus B plus A intersection B. This white shaded portion. This becomes a complete A circle, right? That is nothing but N of A, number of elements of A. See, this portion is NA minus B, number of elements of this pink portion, NA minus B plus N intersection B, this white portion, equals to this complete circle, that is set A, number of elements of A. Similarly, NB minus A plus N intersection B equals to NB. NA union B, NA minus B. See, this is now what I explained number of times. This NA union B is the sum of all three pieces. This A minus B, NA minus B, NA intersection B, and NB minus A. The fifth one is, if you understand the fifth one, all others follow. This means NA union B is this NA A minus B, this, and A intersection B, and NB minus A. All these pieces put together, the sum of all these three pieces is NA union B. The last one is for the three sets NA union B union C. You have a formula for that: NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A plus NA intersection B intersection C. If you are thorough with this, all the problems are very simple to solve, and whenever you get doubt, you come back to this and have a look at this formula and the Venn diagram. So let us start the solution of the exercise 1.6. The first problem is, if x and y are two sets such that nx is equal to 17 and ny is equal to 23 and nx union y is 38, find nx intersection y. This is a pretty easy, direct, straightforward question. Means nx, you will use the second formula. Nx is given, ny is given, and x union y is given. So use this formula to find the number of elements in the intersection of x and y. Just we substitute the values. What are the given values? So just we write down what are the values given. Nx is 17, Ny is 23, Nx union Y is 38, and he is asking Nx intersection Y. So we have the formula. This Nx union Y is equal to Nx plus Ny minus Nx intersection Y. Substitute these values, we get this 38, Nx is 17, Ny is 23, minus Nx intersection Y. Simplifying, we'll get that Nx intersection Y equals to 2. Pretty easy, right? Only thing is, you should remember the formula, which formula to be used. The second question. If X and Y are two sets such that X union Y has 18 elements, X has 8 elements and X has 8 elements, Y has 15 elements, how many elements does X intersection Y have? It's not much different from the first one. We'll get the solution pretty easily. We'll write down all the values with the usual notations. Nx union Y is 18, Nx is 8, and Y is 15. Now we have to find out Nx intersection Y. We have the formula N of X union Y is equal to Nx plus Ny minus Nx intersection Y. Substitute the values, we get 18 equals to, this is 8, this is 15, and minus Nx intersection Y. Simplifying, we'll get this. X intersection Y is 5. Third one. In group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? We'll write down the problem in the notation of sets. Let H be the set who speak Hindi and E be the set who speak English. Then it follows NH is 250. That means number of people who speak Hindi are 250 and number of people NE is 200. The set of E which contains number of people who speak English is 200 and number of people who speak English and Hindi, any one of the languages, remember this, any one of the languages is H union E is 400. Find out Nx intersection E. That means what you wanted to know is how many people can speak both Hindi and English. That is intersection. We use the same formula, substitute the values, we make some place and we'll get the result like this. We substitute the values, we get this is 400 and this is 250, N E is 200 and we have to find out Nx intersection E. Nh intersection E is given by this simple calculation. This is 50. I want to show you the Venn diagram in this. You will fully appreciate the use of Venn diagram with this. I have made some adjustments to bring everything in one page. So this Venn diagram explains this pictorially. See, H is people who speak both the languages Hindi and English is the intersection. Correct. So let it be K. So people who speak only Hindi is 250 minus K. You can see clearly this pink portion. The people who speak only Hindi is given by 250 minus K. That means this pink portion is only Hindi. This white portion is both the languages. So H 250 minus K. 250 is both. So 250 minus K gives you only Hindi. K is both English and Hindi. This 200 minus K is only English. So clear, right? The sum is 250 minus K plus K plus 200 minus K gives you the union of the sets. So A union B is given by 250 minus k plus 200 minus k. That A union B is those number of people that speak at least one language. Remember that. If you understand this, the remaining problems are very easy to solve. We'll move to the next question. Here, if S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T has 11 elements, how many elements does S union T have? This is a similar problem. All the means three values are given. It is asking to find out the fourth value. I am writing down in usual set notation. NS is 21, NT is 32, NS intersection T is 11, NS union T is how much? We have the formula NS union T equals to NS plus NT minus NS intersection T. We'll substitute the values and get the result. NS union T equals to, this is 21, NS and NT is 32, and S intersection T is 11. This is minus 11. The result is NS union T is 42. We will move to the fifth question. If X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection has 10 elements, how many elements does Y have? It is similar to the previous problems. We will write down the values given in usual set notation. After writing down all the values, we use this formula, substitute the values and get the result. This X intersection Y is 30. I am rushing through that because we have repeated many times. The next problem. In a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? Means here he has added one sentence. Each person likes at least one of the two drinks. Actually, in all the previous problems, this holds good. Some elements will be outside the A and B, A union B. So that is not the case. We have assumed that all the means elements are either in A or in B or in the intersection of B. So he has categorically he told each person likes at least one of the two drinks. So now how many people like both coffee and tea? What is that both coffee and tea means? Is the intersection of these two sets. We have to find out. We'll write down all the values given in the question in the set notation. Let C be the set who like coffee and T be the set who like tea. Remember that C is the set of people who like coffee. That includes the people who like coffee and tea also. Here T, people who like tea. The set of the people who like tea. This includes the people who like tea as well as coffee. We will write down the values as per the set notation. Here NC, that means people who like coffee, is 37. The people NT, that means who like tea, 52. And NC union T, that means the total number of people who are actually liking at least one of the drinks is total C union T is 70. Now we'll get the equation and substitute the values to get the solution. With usual substitutions, you will get NC union T is 70, NC is 37, NT is 52, and C intersection T is we have to find out. With simplification, we will get 37 plus 52 minus 70 equal to 90. So NC intersection T is 19. So 19 people are there who like both coffee and tea. The next question is, in group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many people like tennis only and not cricket? How many people like tennis? There are two parts of the questions. Okay. Let's see. I will first draw the Venn diagram for this. So this 10 is the intersection of C and T. They like both cricket and tennis. If you remove this 10 from 40, you will get the people who like cricket only. So 40 minus 10, this 30 is pink portion. 30 is the people who love cricket only. The other one is the people who love tennis is in the green circle. That minus the intersection gives you the people who love only tennis, the green portion. Right? Now we'll solve the problem with the equations. Let C be the set who likes cricket and P be the set who likes tennis. Let C be the set who likes cricket and P be the set who likes tennis. Then, with the usual notations, C intersection T. Sorry. Then, with usual notations, NC union T is 65. Means all the union C union T means all the people who like cricket or tennis or both is 65. Remember, cricket, tennis or both. So next NC is 40 means the people who like cricket and people who like both cricket and tennis, including this. This is NC. This is the C circle. NT is what? This is what we wanted. This is see NC intersection T is 10. Who love both cricket and tennis. That is 10. Now here there are two parts of the means question. How many like tennis only, not cricket, and how many like tennis? See, that is the distinction. The green portion is how many people who like tennis only. How many people like tennis? This complete circle of T is the people who like tennis. We will find them. So let C be the set who like cricket and T be the set who like tennis. With usual set notations, and C union T is 65 and NC is 40. NT is how much we have to find out. This who likes both cricket and tennis is NC intersection T. That is 10. Write down the formula and substitute the values. We get 65 equals to 40 plus NT minus NC intersection T is 10. Simplifying, we'll get this. NT is equal to 35. So what is NT? Is the number of people who like tennis. This complete set is T. That means the people who like tennis, and that includes the people who like tennis and cricket also. Now this is who like tennis. Now we want people who like tennis only, not cricket. Now we need the people who like only tennis, not cricket. That is given by T minus N C intersection T. That is T is the whole circle minus this C intersection T. Gives you the people who like tennis only. This is what? This is 35 minus 10. Gives you who like tennis only. 20 people like tennis only. The green portion is people who like tennis only. Got it? We'll move to the last question. In this question, see, in a committee, 50 people speak French, 20 speak Spanish, and 10 speak both Spanish and French. How many speak at least one of these two languages? That means what you have to find out? At least one of these two languages. That means you have to find out the union of the two sets. The rest of the things follow. It's pretty straightforward. Let F be the set of who speak set of the people who speak French, and let F be the set of the people who speak French, and S be the set of who speak Spanish. All these things will follow. NF is 50, NS is 20, NF union S is what we want, and NF intersection S is given 10. That means the people who speak both the languages. So NF union S is equal to NF plus NS minus NF intersection S. Let F be the set of who speak French and S be the set who speak Spanish. Then with usual set notations, NF is 50, NS is the people who speak only Spanish 20, and the people who speak Spanish is 20. NF intersection S is 10, and F union S is to be found out. So NF union S is equal to, this formula is there, NF plus NS minus NF intersection S. We'll substitute the relevant values and get the result. NF union S is equal to 50 plus 20 minus 10, that is 60. 60 people are the complete who speak at least one language. I think these exercise problems are similar, and the Venn diagram approach and the formula approach, both you should follow. The Venn diagram approach gives you clear-cut picture of the set notation, and complicated problems can be solved using the Venn diagram as well as formula notation.
That concludes the video on solutions to exercise 1.6. In the coming videos, I will give you 3 more things as bonus. Solutions to miscellaneous exercise of chapter 1, solutions to CBS previous year's question papers related to sets, additional questions on sets solving algebraically for your complete understanding of the subject. Hope you understood the concepts and solutions well. Please like and subscribe and share with your classmates and friends to get all the videos of the channel. The link to the videos is given in the description box below. You will get many more videos on class 11 maths in coming days with your support. The aim is you should perform outstanding in your examinations. Thanks for watching. See you then.